Okay, I'm going to talk about wiring up a power LED like this. Okay, wiring an LED on any power supply okay, you will put like a resistor to limit the current. Okay, the resistor, it's depending at the VCC in. By the law of Ohm, you need to calculate that in knowing the draw of the LED, and you can calculate that to put in ohms a resistor that will drop the current on the LED to not burn the LED. But what happens when you have a 3 watts LED like this one? Well, this is changing a little the perspective, because this resistance has to be this this LED will draw like 700 milliamps at 3.7 volts, I think, something like that. So that's a really big load for a resistor. Of course, you can use something like this, which it's like, this is like a 5 watts resistor, but this is this big, and these LEDs you can put it like with a reflector and a 4.2 battery to make like a flashlight. This is a single cell lithium battery. You can put this up here with a charger and make a flashlight, a very good flashlight about this size, that can go into your pocket, can go into your clothes, or I don't know, use it in some way. I had one, it was very good. I have a 1 watt this kind of lantern and flashlight. I'm gonna do another one. So this is a 3 watts. So what you're gonna do anyway, 5 watts from my experience for these LEDs is not enough, and it's big crap, and it will get hot. So what we're gonna do, it's very simple. How do you wire this up? Well, because this is 5 watts, the problem here with the power LED is not the resistance, it's the wattage of the resistance, the power of the resistance in watts. So you can put I don't know, if you put in 4.2 volts, you will probably need like an 100, because the LED goes like only like half a volt under the 4.2 volts. It will be like 100 ohms or less. I don't know, I just invented that. Like it can be like 10 ohms. This 5 ohms can be okay. So I'm gonna actually put this and see what happens. But from experience, I know a 5 watts resistor, it will not it will heat up. So the other thing that you can do is putting a nichrome wire. This is from a heater, and this is the nichrome wire, has some resistance, and is this thin. You can make it in a coil, put it between duct tapes, and it will be a lot more thinner than this. let's try and see how that works. Now I have here, because I don't want to use the lithium battery because it's a very delicate thing, and I don't really want to put it at in this circuit here with all these alligators and short it out, because this is like dangerous. I'm gonna use my power bench, which has a variable power supply, and of course it has like an amp meter, and I can like monitoring the power draw of the LED. Now I have the same LED here mounted at this aluminum bar for use for heatsink. It's hooked up to the power supply, and I'm gonna lift the voltage to until I know this LED goes up to 700 milliamps. So I'm gonna elevate the tension until I have 200 milliamps at 2.9, 740 milliamps at 3.5. So 3.4, 3.5 volts. Obviously I need some kind of power limitation for this LED. This is very bright. It's like full day outside and it still hurt my eyes. So from 3.4 at 4.2, I don't know if it sees here, it will be like 1.5 amps. So I cannot have that. I will burn the LED very fast. So I need to put it some kind of current limitation between my lithium cell which has 4.2 volts and the LED. Let's see if it works with the five ohm resistor at 5 watts. I'm just going to put this in series, see what happens. Well, the brightness of the LED surely go down, and I'm gonna lift to 4.3, 4.2. Okay, with 5 ohm resistor, it doesn't heat up, but sucks like 270 milliamps. This is like less than 1 watt, so I cannot use this, and this is bigger anyway. And no, I'm gonna leave it. Okay, let's see what happens if I put like 700 milliamps. Now it's around like 700 milliamps, and the resistor is getting hot. Of course it's 7.3 volts, but it will be the same because through this resistor are passing by 700 milliamps. So it will probably be like less wattage because it will be like 4.3 volts, but it will still go hot. So that this is big first, and it's getting heat up. So how do I do to put the nichrome wire, and what is the difference? I'm gonna put this in 4.2 volts, 4.2, 4.3. Okay, this has 5 watts. Okay, at 5 ohms, but the nichrome wire has like 2000 watts, and this will not heat up. So we just put it at one side. It has 4.2 volts, and the other one, well, a little farther on the wire. And this is the lathe, but I have 500 milliamps, so I just need to short the distance until the tension, the amps goes to like 700. I have 600, 3.9, 630, now 640, because in this power supply I have a drop of the tension. I need to put a little more voltage until this is 800. Okay, I need to give it a little less. 7.6. Okay, now at 4.5, 4.2 volts, this battery will give this will not have, like with 700 milliamps, this battery will not have any kind of drop of voltage, because this is a very powerful discharge battery. This is a hobby battery. It's for a very powerful discharge battery, so it will not have. This will be like the LED. It's okay, and I need this lathe, and the wire, it's a little hot. It's like, but negligible. It's hot outside, I mean, but it's negligible. Anyway, this battery will have like 4.2, 4.1, and it will be every time less until it gets to like 3.6, 3.3 volts, 3.1 volts. It will suck like 19 milliamps. So at this moment the protection board will cut off the current. The battery will unplug the battery to save the battery, of course. So this is the lathe that you need to put it in series with the LED to obtaining the drop of current that you need. The other option, the technological, more advanced option, it will be like buying a buck converter, which is this size, and needs to be a regulated buck converter from 4.2 to 3.7, but I don't think, and you have to step it out. I don't know, it's very difficult with a single cell, because I don't think the buck converter works like that. You need a step up, step down buck converter, and that will be like this or bigger, and it will be bigger than this resistor, so the better option, it will be this one. Thanks for watching.